Hello, welcome. It's Interfaces Day. We've used the term interfaces before in a more general architectural way to talk about like this layer in between one system and another, or the part that one system exposes to the outside, so that things on the outside can interact or interface or talk to the system in a consistent way, and we can change the system up all we want, and we keep the interface the same. But now we're going to learn about interfaces in C#, like the programming feature, which is different. I mean, they help us do the same thing, but it's different. Interfaces are incredible. They're the best. They're amazing. They're maybe the one tool in my programming toolbox that can best help me simplify code when I need to, which is wild. I tend to lean on interfaces far more than class hierarchy when I want to have multiple objects behave the same way. Because in Unity and with component systems, that just kind of tends to be how it goes. So I'm going to first start with a quick overview of what interfaces are, and then we're going to look at an example, and then I'm going to implement interfaces to sort of fix my example problem. And then we're going to come back and I'm going to do a little bit more formal of a definition of them. And that's the plan. So the quick overview is that interfaces are sort of like class inheritance, but like without all the annoying parts of actually inheriting from another class. The traditional metaphor or description of an interface is that it's a contract or a promise. And I like that promise or contract metaphor far more than thinking about how it relates to classes. The power and flexibility is that we can have multiple separate objects that are separate classes, that are separate scripts, that do separate things. We can all have them implement the same interface and make the same promise to the compiler, to the computer, that they say, hello, I have this function, or I have this method, or I have this variable, or whatever. Not variable. And then the computer can be like, okay, well, I can treat all of you the same, and we're good to go. So an interface is a promise. It's a contract. It's an agreement between the code and the compiler. This class, will implement this interface, and you don't need to throw any errors. So let's look at a problem, and then we will come back and what's the word I'm looking for? We'll come back and dig into what that actually means and go over the definition more formally. All right, I have this project open. I put this together in like maybe 2 hours now, and that feels like more than I should have. This was first just an in-class example, the asteroids thing, but I added some things to shoot. I added a little bomb that will take multiple shots before it explodes, and I added a little enemy that'll like chase you down. So I can move, and it's gonna chase me. It doesn't know about the screen wrap, so the chasing isn't very good. But and then it dies when it gets hit. So both of these objects, getting chased and the charge bomb and the actual original asteroid, which I've just kind of turned off for now, but all three of these things have sort of the same behavior, which is that they get hit by bullets, and when they get hit by bullets, they do something. So let's take a look at the code. So here is the script for the asteroid, which I didn't actually show you just now in the video, but you're watching this because you're in my class and you have this code on your computer. I made a few changes, but basically it explodes and destroys itself, and that's just a public function. And the chase player script gets hit by a bullet and destroys itself, and that's it. It doesn't do anything. But the bomb script, which I've called charge bomb, has a health variable, and when it gets hit, it does take charge shot damage, where it loses some health, and if that health is less than a certain number, 0, it explodes. And then on start, we set it to some serialized variable. And then this little bit is just to change the color. I figure out sort of I turn its health into a percentage from 0 to 1, where 1 is I'm about to die. And then blow it up. using a linear interpolation. We know that one. Okay. So, and then it actually, explodes and it just spawns some stuff and offsets them a little bit randomly and then changes the colors of those things and then goes boom. So that's it. So they all have their functions for how they behave when they get hit. But the thing that actually causes that function call is here in the bullet script. And this is where we have a little code smell. We have some what looks like real repetitive code, where every single time the bullet hits something, it has to check if that thing is a bomb, and then call the appropriate function, and then check if that thing is a player, and then call the appropriate function, and then check if that thing is an asteroid, and then call the appropriate function. Now, there are a number of solutions to this, and the one we're going to use is interfaces, but just to beat you to the punch, the other solution currently is to use the collision event, the fact that the collision events are called on both objects. And we could just have the on collision enter, check if the thing that the asteroid hit was a bomb, was a bullet, and then if it hit by a bullet, then take some damage. But the reason we don't want to do that is because I want to have different types of bullets that have different. Well, the reason we don't want to do that is because this is an example to learn the interfaces pattern. But a reason that wouldn't work very quickly in this project is that if I wanted the bullets to have different amounts of damage that they did, they would need to tell the thing they hit, here's how much damage I do. Now in this game, like an asteroids game, it doesn't really make sense. Things just kind of blow up immediately. But in just about every other bullet game, you'll have different guns that do different amounts of damage. And that's really the bullets do different amounts of damage. And they have some variable with them like damage I deliver, and they'll need to pass that along in a function. I do 1 damage, I do 20 damage, or whatever. So I just didn't bother implementing that in this example because I wanted to keep things just a little bit simpler. And I didn't feel like doing health. And then, the charge bomb is health, but 1 per bullet. Okay, so let's see how we can fix this, because this code, it doesn't scale. As I add more features, I have to add more code to my project in ways that aren't actually directly related to those features. My bullet script is going to have to scale with the rest of my game. And I have lots of ideas for fun mechanics of things that I could shoot and then have do something when I shoot it. Like I could have a whole level with switches. You might imagine an interaction system, perhaps, where you can activate things. Maybe I have switches and doors can activate. You could have all these sort of things that there's this verb that goes between them, activate or interact, or player pick up, or so on. You have this verb that can apply to many different objects. How can we not have to do some code that looks like this? Because this doesn't scale. I dread adding new features to this project. It is awful. I have to keep copying and pasting code. No, none of that. So instead, we want to get rid of all this. We will in a second. First, we're going to make our interface. And our interface is going to be a shared between the asteroid, the charge bomb, and the chase, whatever the other one is, this one, chase player. Now, your second question is, why not use class inheritance? Why not have all 3 of these objects share some parent class, and that parent class could be something like damageable, and then the enemy extends damageable, and the chase player extends damageable, and the switch extends damageable, and the power-up that you can shoot to get a new weapon extends damageable. Ooh, now it's getting weird. And that's why, because often these are separate, unrelated objects, and putting them in that hierarchy is probably going to get in the way of other hierarchies, or just going to be confusing and annoying to deal with. So we're going to use interfaces because it's a better solution. In a project of this scale, to fix literally this project, we could do it both ways and it would have little impact. But join me on an imagination. of just as the project grows in complexity and scope, and you have different types of enemy that will share some behavior, and different types of little switchy things that will share some behavior, and different types of power-ups that will have some parent class to deal with it. Pretty reasonable, and not even that far into the future of work on this hypothetical game, that could be the case. And certainly would be the case in any real project. And I'll show you a real project that uses interfaces in a moment. But we're just trying to keep things as simple as possible to really clearly demonstrate. So let's make an interface. To make an interface, we can add there's a little interface option in Writer. Let's just like add a script and to see what we need to change if we add one from Unity. By convention, we start interfaces with the letter I and then the name of the interface. So we'll make a new script and we're going to call it damageable. Damageable? I hit by bullet. I take damage. Damageable. Bullet hitable. I should have thought this far through. Damageable. I damageable. The I stands for interface. Probably already open. There you are. Okay. Now this interface, a few things to know about it. It's not a mono behavior. It doesn't have these functions, and it's not a class. It's an interface. Oh. Keyword interface. So to declare an interface, we give it a scope, we give it the keyword interface, and then the name of the interface. That syntax should begin to look very familiar by now. And then it says that's not, this is my type. My green is my typo. There's no E. Damageable? There we go. Let me rename the script. This is important to me. Okay. Damageable. There we go. Damageable. And then we can declare any of the methods or functions or members of what have you that this interface, anything that implements this interface should implement. Which is to say, when I say implement, I mean have a function with that name. Have a function with this name. So we're going to make one, and we're just going to write out the whole function. And the problem that we're going to face, if we do like debug.log, is that C#8 allows us, is different than C#7. Interfaces can implement functionality. I'm getting a different error. I'm not getting an error I thought I would get because we're in... Okay, I double checked. That C#8 does allow you to declare the actual default implementation of a function, and we're not going to do that. Because that's a new, well, I mean, C#8 isn't new, but it's new to Unity, so we're not going to touch it. Yeah, we're just going to do a little semicolon at the end of the function name. That's it. There's no functionality here. Interfaces, we're not actually implementing any code. We just say, this is the name of my function call. This is what I am called. You can call a function here. But the interface itself is like metadata for the code, for the compiler. It's not actually like a thing in your project. So let's go to the asteroid script that has this explode and destroy self. And let's have this script implement the interface. I need this script to have a function called take damage. And then I need to tell the compiler that it is a member of this interface and thus has this function. So I damageable, we just add it like a little comma here. With a little comma here. We have a class and then we just add it like you would extend another class, but we can do more than one, which is the real power of interfaces. We can implement multiple interfaces and you can't extend multiple classes. So I'm getting an error, and the error I am getting is that I don't have a take damage function. I have broken my promise. I said to the compiler that I am damageable, and the compiler goes, well, damageable means that you have whatever is declared in the interface, and you don't. So that's an error message. So let's implement it. All I need to do is implement that function. So I need to have the same scope, the same function name, and the same the same method signature, the same parameter types in the right order. It's all got to match up. The way I like to do it is to not think, and I use JetBrains Writer, and I go Alt-Enter, implement missing members, thank you very much. It has generated it for me, which here we only have one. You can have more than one, but here we only have one. And in this case, we just want to call this function, but frankly, we don't even need to call it. We just need to just get rid of it. And I will implement the functionality of this interface. Great. Now let's go to another script and let's do that again. So my chase player will implement damageable, and I will call hit by bullet, whatever the function I called, and then my error message goes away. Very good. And then charge bomb. Actually, we'll call that take damage, and we will. Just having a function with the same name doesn't mean we've implemented the interface. We got to do this little. You have to say so. So now in C#, I've got these, in the bullet script, in the bullet script, I've got these errors that are like, hey, this function doesn't exist. And you're right, I've renamed it. I've done nothing. So, okay, errors are gone, but I haven't solved my problem. And here's the real solution. Here's the real magical part. Is instead of looking for a charge bomb component, or a charge bomb mono behavior, I'm gonna look for an damageable mono behavior. And if I have an damageable mono behavior, then I know that it has the damage. The only thing I know about it is what's declared in the interface. Whoa. Back. Where was that? The only thing I know about it is that it has this function, but it must have that function or we will get an error. So if we have compiled successfully, then I know that function exists. I know I can call it. I know how to find it. Or the compiler knows how to find it in memory or whatever, knows what to do, and it's not going to freak out. IDamageable will return any component on the game object, because this is looking for mono behavior, so it's looking for any mono behavior that implements this interface. And then it'll find all of them. It'll find any of them. That's it. Look at that. We went from this to that. Boom. Oh, I love it when writing code, it uses the delete button. Isn't that a good moment? And now I only do two get component calls. I could probably clean that up. Var other damageable. There, now I only do one get component call instead of 3 to 4. And now I can just not touch the bullet script, and I can go write more IDamageable things and more scripts that implement IDamageable, and they'll just work with this code without me having to touch this code. And that's really the beautiful part. So we've seen some interfaces before. In coroutines, enumerator is an interface. We don't really care about how it works, but just for what it's worth, it's an interface. Is that really all we've seen? I think that might be all we've seen. But that's it. So let's just test that it works. You know, I'm sitting here concluding. I'm like, we did it, but like, let's make sure it still works. Yeah. Yeah. Let's turn that asteroid spawning back on. Yay. Asteroids. I haven't fine-tuned the movement yet. It's not fun to play at all. So now I can add more functionality, and I add more scripts that only deal with the new code, the new behavior, the new whatever I'm writing. I don't have to touch any of that other code, and it'll just work. And I like that. I really like working like that. So let me show you real quick another project. This project is this puzzle game. I'm sure I brought it up in videos before. I will finish it like eventually. But the puzzle game this puzzle game is pretty simple. But underneath, behind the scenes, I've actually written an entire like framework for making little Sokoban push block puzzle games, so that I can use this framework and do a game jam and just like I have everything any idea I have come up with for puzzle games. I've tried to put into this overly complex framework. So if we look at that framework, ooh, wow, look at all this code. If we look at that framework, we just scroll down and look for anything beginning with the letter I, and we can see the different interfaces that I've used in this project. This one involves deleting objects that have to fade out before they actually get destroyed. So that's a thing. I laser activated, and I had lasers, tripwires. And when something gets hit by a laser, it needs to start listening to the laser's source to see if it gets turned on and off. So it's got like, it needs to know about that. Condition is probably the the biggest and most important interface. It only contains one thing, which is just some true or false statement. But all of my victory, all of my, whether you've won or lost, or all the blocks in the same place, or all the things in the same, the doodly doos are in the same biddly bits. Does the mirror get hit by a laser? Are the enemies dead? Are the whatever the win conditions or lose conditions of the game are? If it implements I condition, that means I can use it. And that could be checking my turn manager if I haven't used too many turns, which is completely separate than checking if my game object is doing something over there, and so on. Bidirectional dictionary is an interface. That's a weird one. Command system. My command system. Frankly, I kind of want to refactor it, but I have different commands that all, move is a command, and paint is a command, and the command manager just works with them as a list of commands. Doesn't really care what they do. It just hangs out on its own. And is that all my interfaces? Level manager, it's got a level collection interface. I kind of don't use it and should refactor it. Gosh, I should use this project more. There's a lot of good stuff in here. I write all the code and then I don't actually make the game, and I just do something else. That looks like it. Yeah. So interfaces are really, really nice. When you're programming and you're like, I need you just to call this function, and the code's like, oh, I don't know that if you have it or not, I don't know what you're doing, and you're like, please. Interfaces are probably the solution for you. Because they allow the compiler to very confidently call functions and whatever on so on. They must. I lost my train of thought. I started reading and talking at the same time. They allow you to just make everything nice and separate and compartmentalized and extensible and flexible. The documentation page on C# goes over interfaces in more detail. I recommend everyone, well, my students, you'll be assigned to read this, but I recommend everyone quickly read through this. It's got a lot of stuff we maybe haven't talked about or learned about yet, but summary. Give it a look through to see what you can and can't do. You can't do data fields. You can't do auto properties. What are those? Who knows? But yeah, I said I would define interfaces more particularly, but I think I elaborated during the video on them, and I'm gonna send you to other resources, reading resources and example resources, and we'll get it all wrapped up in a nice bow. Because this video is already too long. So see you then. Goodbye.